Inverse normal distribution is where we know an area, a proportion, or a probability, and we're going to use that to find the x. So we find out what our range is based on the probability. Right? There's a couple of different varieties of how we're going to do it, so we're going to have a look at this. Again, I'm assuming that we have the Casio graphics calculator, and all of my working is going to be based on that. Okay, so let's have a look at this question here. A normally distributed random variable has a mean of 6 and a standard deviation of 1.5. Find the upper and lower quartiles. Okay, the first thing I do whenever I see a problem like this is I draw a picture of it. We have our standard normal graph. Oh, let's try that again. Hopefully with it not cutting out. Nope. Try it again. Screen doesn't always respond perfectly. All right, standard normal graph. We have our mean of 6, and we have a standard deviation of 1.5. I'm not going to draw the standard deviation, so it's going to get down road for what I'm wanting to do. Now, what we're wanting to do is we're wanting to find the upper and lower quartiles. So we're going to find what's the point where 25% is below, and the point where 25% is above. Right? So those are the two things that we're wanting to find. We're going to have we're going to look at three different things when we do this. Right? The first one is just using the basic inverse normal, and we're going to find this one here with the tails to the left. So here we've got the tail, the bit that we've shaded is to the left of the line. And so that line there, if we're going from the very left, is 0.25. So what we need to do is we need to go into our calculator. We're going to go to stats mode. Oh, let's do this. And then we're going to go distribution, which is F5. F5. Right, and then we're going to say it's normal. F1, and then we're going to go to inverse normal. Which is F3. And once we're in here, the options that we have are the data is it a variable or a list. We're going to use a variable. The tail, is it left, right, or center? So we're going to select left, which is F1. The area, that's what's the probability, 0.25, the probability of the proportion, so 0.25. And then we put our mean and standard deviation. And we get in here our x inverse. And that comes out to 4.988. 4.988. Right. So that's our lower quartile. We can then go back the same thing and do it with a right tail. And that gives our upper quartile. Right. .012. So our lower quartile is 0.4988, our upper quartile is 0.7012. Now the other option we could have done for this one is we could have used the center option. And so instead of left to right, we use center. And for that one there, this time we'd want the central 50%. So the center of 0.5, we put that in, and it comes out with the same numbers. That gives us x1 and x2. So rather than doing it in two steps, we can do it in one. Okay, so here's another normal distribution problem. This is an inverse problem. What we've got here is the lengths of kiwi fruit at harvest are normally distributed with a mean of 6.5 centimeters and a standard deviation of 0.9. So if we draw our graph of it, try that again. That'll do. We know our mean here is 0.9 is 6.5 centimeters. We have the smallest 15%, so we'll do that one in red. 0.15. The smallest 15% are called kitty. And then the largest 20% are called giant. So what we're going to do here is we're wanting to find, for the first one, we're going to find the left, the tail to the left, where there's 0.15 as our, and so we find that number there, our x number here, we've got x1 equals 5.567, and our x2, we're going to put the tail to the right. We're going to put 0.2 as our area, and we're going to get 7.257. Okay, so what we have to do now is we have to find a way to explain what's going on here. And so what we can do is we can say that kiwi fruit that are less than 5.6 centimeters are called kitty sized, y. And then kiwi fruit that are more than 7.3 or that are 7.3 centimeters or more are called giant. Giant kiwi fruit. That there. And so by doing that, we've now explained what the crossover is. Once it reaches 7.3 centimeters, it changes its name. Up until 5.6, it's called kitty size. Once it reaches 5.6, it changes to normal. And then at 7.3, it changes again to being called giant. And that's inverse normal. So here's a problem for you to do. Right, an ice cream machine puts ice cream into small tubs. The amount that it puts in is a normally distributed random variable with a mean of 78 mils and a standard deviation of 4 mils. The company selling the product wants to have at least 90% of the tubs having more than their advertised amount of ice cream in them. So in other words, the amount they advertise, when they pick out one at random, they want there to be a 90% chance of that having more than that amount. So less than 10% being below that number. Right? Find what size they should label the tubs as holding.